What is up, guys? Buchanan here from Latium Technologies, Niskew's best kept secret. Today we're going to be taking you through some of the latest developments in our cable management technology for our IoT solution, Yondr. But first, a little bit of backstory. In 2017, Suncor approached Latium to help develop a solution for their ore mining operations in Fort McMurray. You see, Suncor utilizes a network of high-voltage cables to power their fleet of excavators used in the recovery process. Cables are often spliced together, creating lines that can run for multiple kilometers. In order to keep track of cables and determine approximate cable lengths, teams of technicians are tasked with walking the line and filling in manual reports. These reports can take anywhere from up to 1 week to 30 days. Suncor needed a solution that could help track individual cables, offer insight into cable configuration, and provide total cable length. So that's what we did. We started by developing a custom sensor that could attach directly to cable potheads and/or connectors. This sensory data is captured by our Yondr Edge devices, pushing data to a web-based application to help visualize messages using our mapping tool. However, this was only the beginning. Our team didn't want to just track cables, but rather provide insight on cable health, enabling those teams to pinpoint damaged cables in the event of a sudden loss in power. But more on that later. To do this, we would need to rework our sensors to include a ground-isolated induction coil to detect power through the cables non-intrusively. Moreover, these new sensors would require built-in nanosecond accurate clocks to record the course order of a sudden drop in power. If a cable was cut, the line begins to de-energize. Using built-in edge computing software, our parent hub will determine the sequence the sensors detect the change in power to determine the location of the damaged cable. Working with Rick Wang from RWIoT Technologies, I was asked to chronicle our methodology and progress to date. Hi guys, Monday, November the 16th, here at Latium Technologies, Niskew's best kept secret, and I'm going to be chatting with Rick Wang today. Okay, Rick, I just want you to tell us a little bit about what all this is on the ground and what we're trying to accomplish today. On the ground, there are some cables, wires, and signal generators. We're trying to build a test system, something to test our concept and prototype sensors to detect if a cable is damaged. Our sensor will be able to quickly capture that signal. We'll build a simulation test network to do that. It's a real-world simulation in a lab. It is Monday, November 23rd. We're heading in the back to see what Rick Wang is working on today. The first thing I did when I got in this morning was start working on GPS modules. I'm using the GPS to time parts per second time signals. I'll use that to sync to the real-time internal clock within the sensor. Just got in from lunch. We're going to be seeing what Rick Wang is up to right now. Rick, do you mind telling us what you're up to right now? Yeah, we hooked up with a 3-phase 480-volt power source. We start with a smaller voltage in these test scenarios before working our way up to a real-world scenario. So when we flip this switch, this chart demonstrates the rapid signal change that comes from when a cable is damaged. This is a prototype of our sensor. This antenna will be used to measure that change in signal that comes when a cable gets damaged. So, to recap, in 1 month we have successfully set up an in-house testing location, configured GPS modules with our sensor's internal clocks, and proven that we can visualize the drop in power. Want to find out what happens next? Follow us on LinkedIn or visit us online at thelatiumgroup.com.